Hello and welcome back to another session of Effective JaRu, the series where we read effective Java and try to port the items over to idiomatic Rust. So in item 18, it's about interfaces and abstract classes, saying prefer interfaces to abstract classes. Why would that be? I mean, generally, if you inherit stuff, this is what we learned so far, you opt into a whole lot of implementation details that can be problematic. It's difficult for the subclasses to get it right as well as for the superclasses. So interfaces are a way around them, which, I would say they're similar to traits, but with an important difference, I say. So let's first get item 18 going here and see what we can do to simulate this. Well, maybe we can't simulate anything here, but let's have a look at the example. So implements means that an interface is implemented, right? So there's this map entry interface. And first of all, interfaces, they really just are interfaces. You cannot have default implementations for this, which is a huge bummer. For instance, if you look at, interfaces are similar to traits, except for traits can provide default implementations. For example, if you look at the iterator trait, you will see that it only has one required method, which is next. And provided methods are the ones that you can override, but also the ones that are pre-implemented based on the single available next function here or method here, which is amazing. So basically interfaces are a version of or a kind of trait that only allows required methods and not provided methods, which is limiting. However, Java also supports abstract classes, which basically allow you to say, well, I want to pre-implement certain methods, but want to leave others for implementation by the subclass. And then self-calling is part of the deal, right? Because the abstract class will then implement or provide implementations based on calling itself on the methods that are provided by the subclasses. So how does that work? For instance, here in the abstract map entry, and now to finish this train of thought, I guess, in the moment you want to have an interface that has an existing implementation, what you have to do is to use an abstract class that implements the map entry for you and just leave some abstract methods left for you to implement. But in that moment, you obviously force someone to extend your map entry here, or extend your abstract implementation instead of implement, which kind of makes you inherit the implemented interface here. But of course, this changes semantics because all of a sudden you are an abstract map entry instead of something that horizontally adds or implements a certain interface here. To my mind, this forces you to combine orthogonal concepts with each other, because is-a relationships have generally nothing to do with something that provides certain functionality, right? And I mean, class hierarchies, they tend to be limiting anyway, because every, I think it's called a taxonomy, is something arbitrary. You can see it from that perspective, and things change over time, whereas taxonomies usually have to stay stable forever. So you are usually better to just implement certain, well, let's call it traits, because that keeps it very, very flexible. So in Rust, you can have, and that's very common as well, you can have implementations of methods that use one of the required methods here. The cool thing is when you define that thing, there's no need for you to actually, I want the source. There it comes. There's no need for you to do anything weird with abstract and blah, blah, blah. It's just, it comes naturally. And of course, everything that is part of a trait is public by default, because otherwise traits would make no sense, right? So as you can see, size hint is pre-implemented as kind of non-existing here. Because if you are streaming iterator, you have no known size, so that's a valid default implementation. But obviously you want to implement this if you have your own kind of collection going on. And yeah, it's really interesting. All this, look at this, it's really simple, really short and neat. But if you would have to provide all these implementations yourself every time you want to provide an iterator, damn, you would be totally doomed. Would be no fun. And if you, yeah, I'm very happy that Rust solves it that way, because it combines the strength. I mean, basically has everything you want. Whereas in Java, it seems you have to do some dance around the fact that for some reason interfaces cannot have a default implementation, or cannot call themselves, that is. And I really wonder why that is. Probably it has to do, well, yeah. The thing is that traits also, you cannot only make calls to yourself in a trait, you can also make calls to, yeah, well, yeah, I think that's pretty much it. I just want to say something that probably is wrong anyway, by saying that thanks to type bounds, you can basically, yeah, no, forget what I just want to say. Something that I would like to say anyway, something that you can observe here. So first of all, these two are abstract, so you have to provide them in order to make this thing functional. So that's the read-only, non-mutable operations, right? And look at this. It's not indicated that these are not mutating, because in Java you can't do it. Whereas the mutating one, set value, all of a sudden is implemented with an unsupported operation exception, because if you have a non-modifiable thing, or let's say by default, this is supposed to be non-modifiable, and if you want to be modifiable, you have to override it, which is super interesting, because this means at compile time, I mean, we knew that before, but here you go. This is how it's done in Java. Mutability is shifted to runtime exclusively, and if you make a mistake there, well, it's a bug, and all of a sudden things start to fail because, well, there's no compiler that helps you to check that, as you can do it in Rust, which is quite amazing. I mean, it's as unsafe as it gets in a way, and there's no way around this, basically. Yeah. So what can we say here? Traits allow implementations of its own method, of its own interface, using calls to itself. See the iterator trait for a perfect example. Yeah, so there is no such thing as inheritance or abstract classes, and I think it's a great thing not to have that. The only thing that I'm missing in Rust is, well, is the fact that you can not downcast, right? You can upcast, but you cannot downcast anymore. You lose that type information unless you store it yourself. So there are ways around this, but it's always a way around it. It's always a workaround in a way. And this is something you have to remember. When it comes to entity relationship systems or entity component systems, then being able to downcast is a cool thing. But on the other hand, you can write unsafe code or resort to a crate which deals with these details for you. And there are crates that do that already. So I'm just saying, downcasting is not easily supported in Rust. It's an unsafe thing by definition. And there's no language feature that would support that just yet. But of course, third parties kind of hooked in there and provide help. Yeah, the second thing I would like to address here, once again, basically, is the hashcode API, which I think is totally broken. As I said before, it can't be that you have to implement your own hashing algorithm here. It's just, it's so error prone, it doesn't get worse really. What I would like to do is probably call hash code on these guys here and then just use that. Oh, it does that. Oh, great. But how do you know that this is the right thing to do? I mean, I've no idea, because I'm not someone who has any idea of how to implement good hash code. So the algorithm really should be separated here, and just having 32 bits for that also is probably not a great thing. So generally, using hash maps in Java is probably a bad thing to do, just because of the weak hashes that you get by default. I mean, come on, there's no way around it. That's just bad. So here, the second example, interarrays, concrete implementation, build a topic skeletal implementation. So that's a basically factory pattern here, which allows you to have an adapter of a list that adapts an underlying concrete array of integers. So you basically have a boxed version of a list that is implemented using an underlying unboxed version of a plain int array. And what I find interesting here, and this is kind of, it's a good thing, because I think in one of the first episodes I said, well, there are no closures, and closures usually means that you can bind your environment to the closure in some way. But this happens naturally here. Look, you have this static factory method here. And what you do is you use the abstract list for integers, and then you implement certain things. What I ask myself, then you implement certain things, and you just naturally use the A here that obviously comes from somewhere else. It's really just an adapter, because all you do is convert values on axis. But still, I wonder why there is no override here in the get method. So if we run this, I think first you have to compile it, then you can run it. What happens if I don't provide that? Is there some problem with this? I mean, is this abstract in the abstract list? I would think so. Yes. Is not abstract and does not override abstract method get. I see. So why is there no override annotation here, huh? Is this a bug? I think you want to have override here. Totally. I think override is an annotation that basically tells the compiler to verify that you truly override something. But what you also see is that it's purely optional. And obviously this is because it was added later. These annotations might have been added with Java 1.x. And this is why they're optional. And I think that's an oversight here not to specify it, because you definitely want to override something, right? The cool thing is, if you want to have a trait that you want to implement, we could do this here just for the fun of it. We could have my trait, or I have a, in the book there is an example here of a singer. Is it? I thought it was here somewhere. I've read it. So where is it? Here it is. So we can implement this for the fun of it. So we have an interface singer, which is our trait singer, which can return an audio clip, which sings a song and returns an audio clip. fn sing, which gets a song and returns an audio clip. Fine. And now we want to have struct song and struct audio clip. Just a unit struct here. It has no data, but it's a concrete type nevertheless. Then we have a trait songwriter, which can write songs, I guess. Compose. A hit possibly, and that one returns a song, right? And that is that. And now we can have an artist who implements these things. So impl singer for artist, which will say, well, we can sing a song and return an audio clip. And as you see, there is no need for us. Actually, we can also skip this one. If you put an underscore, then the compiler won't argue with us that we didn't use that one while still kind of documenting it. So as you can see, I don't need to specify I want to override this, because if I wouldn't override it, the compiler would barf, just because it knows that I'm implementing singer for artist and knows exactly which functions or with which methods I have to write for that purpose. Right, so right now I don't have anything here worth mentioning. Artist is never used. That is true. So let's also implement impl songwriter for this artist, because it's really a multifunction or functional artist. So it can compose a hit, and again, we don't really care about it. And this returns a song, right? So here return a song, and now I can just test the artist and say artist. Yeah, let's keep it. Let's keep one. Oh, by the way, right now that's interesting. These are static methods that I have implemented, right? So in fact, I want to say, well, if we sing a song, well, can we change our state or not? So that mutability question is something we didn't ask before, but now I could say, well, actually, this is allowed to change ourselves. And same here, because we can gain experience in something like that. So yes, this must be like that. And now all of a sudden, we can't compile it anymore, just because we are not actually implementing the right method. So method sing has a mat self declaration in the trait, but not in the impl. How great is that? That's awesome. So yes, mat self. Same here, mat self. And now this should compile again. And yeah, we could now just create an artist. Yeah, that's actually, if you have nothing there, then this is all you need to create an actual instance. And now we can say compose a hit. Using this with true and false is bad. Probably you want to use an enum here. And I guess in Rust you would do enum song type right away, just because it's so easy, right? So we have hits and normal songs. Hit and flop. Let's call hit and flop. And now we can basically song kind, by the way. It's common because type is a keyword. It's common to call types kind, and that makes total sense too. So kind is a song kind, and now we have a much nicer interface that I actually totally prefer. Kind, song kind. Yeah, we don't use it, so do it like that. And now we can say we want to compose a song kind hit, and we sing it ourselves to get an audio clip, assert. Yeah, we can't compare the stuff yet because it has nothing. So we can just leave it like this. We can obviously make it comparable. But in this case, as long as it's really nothing, it makes no sense. to us. Ah, that is true. I mean, that is true, I think, in stable still. The problem is that right now we don't realize that this borrows A, right? Because it provides a mutable self, and then it tries to sing here, which also needs a mutable self. And it doesn't realize that this call actually finishes before that call is made. In nightly, this might be different already. So let's see if that is indeed the case. No, that is sad. But there is an RFC for this to change this, just because it's not exactly true here. So we can have a song. We can have a song here that is a song we just composed. We just basically refactored this a little bit, and now this will be fine. It's probably also the better code. But hey, what can you do? So as you can see on Nightly, you have nice colors, which I like. You do not have that elsewhere. Yeah, this is it. Long story short, I think it's quite cumbersome and error prone to kind of emulate the traits that you have in Rust, even though you can do it. You can always implement an interface fully in Java, but these interfaces tend to be quite fat, as far as I have seen it, which means that it's cumbersome to do so. You probably want to use multi-inheritance and then go ahead and start off with an abstract implementation. Just implement 2 or a few abstract methods yourself to save some time. Makes sense, but it is more complex than it has to be. Also nice to see that we have indeed closures and combined to other variables. What's not nice to see, I mean, in case it's not obvious, the provider of A can still access A after he has provided it to us, which makes it kind of difficult to be sure about things here. It's pointer aliasing basically, because we can now access it through the list that we return, as well as through the actual data source. And that's a problem. This will lead to errors if you are not aware of this. So this really should be moved here, but there is no such thing as move semantics in Java, unfortunately. In Rust, this wouldn't be an issue at all. That should be it for this session. Thanks for watching and have a great day.